This is the PLSS, the Portable Life Support System, a 40-pound machine strapped to your back that does something remarkable. It keeps you alive on Mars. Mars wants you dead. The atmosphere is 0.6% the density of Earth. There's no oxygen to breathe. Temperatures swing from -80 to 20 degrees Celsius. Radiation bombards the surface with no magnetic field to stop it. And you? You're a biological machine that needs 3 things every second: oxygen to breathe, heat regulation to function, and power to monitor it all. This backpack provides all 3. It's not just a tank of air. It's a closed-loop life support system, a miniature spacecraft engineered to fit on your back. Let me show you how it works. We're going to open this machine layer by layer, strip away the outer shell, expose the systems inside, and understand why this might be the most sophisticated piece of personal equipment ever built. Because if this fails, you have 90 seconds before you lose consciousness, 2 minutes before permanent brain damage, 3 minutes before death. So let's see what keeps that from happening. First, let's talk about breathing. You consume about half a liter of oxygen per minute during moderate activity. On a 6-hour EVA, that's 180 liters of oxygen. You could carry that in tanks. But high-pressure oxygen is heavy, dangerous, and you'd need massive tanks. The PLSS does something smarter. It recycles your air. Watch this. Every breath you exhale contains roughly 4% carbon dioxide. That CO2 is toxic. Let it build up and you'll be unconscious in minutes. So the PLSS has to scrub it out. Here's how. Your exhaled breath travels through a ventilation fan. This pushes the contaminated air into the primary oxygen ventilation circuit. Think of it as a closed loop. Air circulates from your helmet, through the backpack, and back to you. But along that path, it passes through a carbon dioxide removal assembly. Inside are lithium hydroxide canisters. Lithium hydroxide is a chemical that loves CO2. When they meet, they bond. The CO2 gets absorbed. And what comes out the other side is clean air again. Each canister can scrub about 1 kilogram of CO2 before it's saturated. That gives you roughly 6 to 8 hours of operation. But here's the elegant part. The system doesn't just remove CO2. It adds fresh oxygen to replace what you consumed. There's a high-pressure oxygen tank mounted in the PLSS. It feeds pure O2 into the loop at exactly the rate you need it. The system monitors the oxygen partial pressure constantly. Too little and you suffocate. Too much and you risk oxygen toxicity. The regulator keeps it at 0.3 atmospheres. Perfect for human respiration. This is a regenerative system. You're breathing the same air over and over, cleaned, refreshed, and circulated. It's the same principle used on the International Space Station, scaled down to fit on your back. Now let's talk about heat. This is where things get counterintuitive. You'd think the problem on Mars is staying warm. And yes, the ambient temperature is freezing. But inside your suit, during physical work, you're generating heat. About 400 watts of metabolic heat. That's like having 4 incandescent light bulbs running inside your suit. On Earth, you cool down through evaporation, sweat, air circulation. But in the near vacuum of Mars, there's no air to carry heat away. You can't sweat it off. You can't radiate it fast enough. So without cooling, you'd overheat in minutes. Your core temperature would climb. You'd experience heat exhaustion, heat stroke, and eventually organ failure. The PLSS solves this with a liquid cooling and ventilation garment. It's a tight-fitting undersuit woven with thin tubes. Cold water flows through these tubes, pressed against your skin, absorbing heat directly from your body. Here's the water circuit. A reservoir holds about 4 liters of water. A pump circulates this water through your cooling garment. The water absorbs your body heat and returns to the PLSS warmer than when it left. But now, you have hot water. You need to dump that heat somewhere. And this is the brilliant part. The PLSS uses a sublimator. A sublimator is a device that uses the vacuum of space itself as a heat sink. Here's how it works. The hot water from your cooling garment passes through a porous metal plate. On the other side of that plate is exposed to the Martian near vacuum. Water is fed onto this plate. The vacuum causes it to sublimate. That means it goes directly from liquid to vapor without boiling. This phase change absorbs enormous amounts of heat. It pulls heat out of the system and vents it as water vapor into space. It's the same physics that makes you feel cold when you step out of a shower. Evaporative cooling. Except this happens in vacuum, and it's incredibly efficient. The sublimator can reject 400 watts of heat continuously. Exactly what you're generating. It's a perfect balance. You stay at a comfortable 37 degrees Celsius. Not too hot, not too cold. All of this, the fans, the pumps, the sensors, needs power. The PLSS carries its own battery system. Mounted in the base are silver zinc batteries. These are rechargeable cells chosen for their high energy density. They provide roughly 500 watt-hours of power, enough for 6 to 8 hours of operation. But the battery doesn't just power things, it enables intelligence. The PLSS has a caution and warning system, a network of sensors constantly monitoring every critical parameter: oxygen pressure, CO2 levels, water flow rate, battery voltage, suit pressure, temperature. If any parameter drifts outside safe limits, the system alerts you. Visual warnings in your helmet display, audio tones in your headset. The system tells you what's wrong and how much time you have to fix it. There's also a biomedical monitoring system: heart rate, respiration rate, core temperature. This data is transmitted back to mission control in real time. If something goes wrong, they know before you do. And here's the critical part. The PLSS has redundancy built into every major system: 2 oxygen tanks instead of 1, 2 lithium hydroxide canisters, backup fans, secondary power buses. If the primary system fails, the backup engages automatically. The system is designed for a single-point failure tolerance, meaning one thing can break and you still make it home alive. This is fault-tolerant engineering, the kind used in aviation, in nuclear power, in anything where failure means death. Let's talk about what happens when things go wrong. Scenario 1. Your primary oxygen tank ruptures. Micrometeorite impact. Manufacturing defect. Doesn't matter, you have seconds. The system detects the pressure drop instantly. An automatic valve isolates the damaged tank. The secondary tank opens. Your oxygen supply continues uninterrupted. You have enough reserve to abort the EVA and return to the habitat. Scenario 2. The ventilation fan fails. Without air circulation, CO2 builds up around your face. You have maybe 2 minutes before you pass out. But there's a secondary fan. The moment the primary stops, the backup spins up. Airflow resumes. The only thing you notice is a caution light. Scenario 3. Total power failure. Both batteries dead. Every electronic system offline. You still have 30 minutes. The suit maintains pressure mechanically. You have residual oxygen in the loop. And there's an emergency oxygen supply. A small bottle with a manual valve. Enough to get you back to safety. This is engineering for survival. Every system has been tested, retested, pushed to failure in vacuum chambers, thermal chambers, and on analog missions in places like Devon Island and the Mojave Desert. The PLSS represents 40 years of life support evolution. From the Apollo backpacks that walked on the moon, through the EMU suits that built the International Space Station, to this, a system designed for the harshest environment humans have ever attempted to work in. 40 pounds of titanium, Kevlar, aluminum, and electronics. A machine so sophisticated it can keep you alive in an environment that's actively trying to kill you. This is the PLSS. And when we go to Mars, this goes with us. If you want to see more engineering deep dives like this, subscribe to Project Ares. We break down the technology that will take us to Mars. Hit that notification bell so you don't miss the next video. Thanks for watching.